students. Greetings of the session. This is the new module, Transient Behavior and Initial Conditions. So in this, we will study what do you mean by a transient behavior. So first, I'll take an example, real-time example. I hope all of you are sitting in a room, right? And in the room, fan is switched on, right? Now, just switch off the fan. So what will happen? Initially, fan was rotating at a certain RPM. As you switch off the fan, will it come to zero immediately? No. The speed decreases gradually and it comes to zero speed. Correct? Now, at the same time, after coming to zero speed, if you switch on the fan from this zero speed, what will happen? It will gradually increase and after some seconds, it will come to a fixed RPM. Correct? Now, that means here, if I consider the plot, it may start from 0, gradually increasing, and it is reaching a steady state in the later case. Or in the first case, it is in a maximum speed. After some time, it is coming to 0. Correct? In both the cases, it is attaining the steady state, constant value, after some period. Here also, correct? This period is called as transient period. So this period is transient period. Now, behavior of the system during this transient period is the entire topic, analysis of the transient behavior. Now, suppose you have already switched on the fan from the 0 and it is running. Before attaining a steady state only, if you switch off, before attaining a steady state final value, if you switch off, what will happen? Suddenly it will decrease the speed and it comes to 0. So initially increasing, then a drop, then decreasing. That means whenever there is a switching or exchange of the supply, change in a supply input variable, then the system behaves with some uncertainty. Correct? It is gradually increasing. In this case, it is gradually decreasing. So, this behavior, once again I am telling, as transient behavior. Now the question is, why this transient behavior analysis is required? Now, in the previous example, I have considered the very simple graph gradually increasing and then coming to steady state. But that may not be true, because as you are giving a supply, it may oscillate for some period and then it may reach a steady state. Correct? This oscillation is such a way that there is a big difference between the steady state value and this maximum peak value. So if this difference is very large, it may damage the system. Right? So this is the steady state capacity of the system which is designed. But during the transient, if it goes beyond some limited value, suppose the limiting capacity is this one, then if it goes beyond this, what happens? System breakdown. System breaks. So before implementing any system design, we should check what is its behavior during a transient condition. So that is why this transient analysis plays a very much important role. Now, here three things we need to study. Now, transient behavior, as I told, it is the behavior of the system against the sudden change in an input. So, the sudden change in an input, I will consider sudden change in an input, or it can be also called as switching. Because of the switching, this sudden change in input takes place. The switching takes place, I will consider as takes at t equal to 0. Now, whenever there is a change in input, the instant at which this changeover takes place, we will consider as a 0. So, immediately after switching, what is the behavior? That is considered as t is equal to 0 plus. That is known as initial condition. Initial conditions. I will explain in detail about the initial condition in upcoming slides. Similarly, the behavior when it attaining a constant value or a steady state value, that is considered as t equal to infinity. That is considered as a final condition. So in upcoming slides, upcoming videos, I am using initial condition as t is equal to 0 plus and final condition as t is equal to infinity. Okay, and by assuming a condition that this changeover switching operation takes place at t is equal to 0. So all the further discussion in upcoming discussion, I will considering t is equal to 0 as a standard switching time and 0 plus is the initial condition, 0 minus. Now coming to the specific to electronic devices. Electronic devices consist mainly three types of elements. One is resistors, capacitors and inductors. So all the elements are either energy consuming devices such as resistor where heat is dissipated, energy consumed in the form of heat, or energy storing devices. All the elements in the electronic devices, gadgets, all consist of these three components only. Nature is similar to either resistor, capacitor or inductor. So it is very important to study the behavior of the network. It is very important to study the behavior of each and every individual element. So what happens when switch is closed or switch is open when there is a resistor? What happens to the element capacitor when sudden change in an input or switching takes place? Or what is the behavior of the inductor? So these element behavior we'll study in the next video. next videos. Okay, so mainly remember, transient behavior is the behavior of the system when switching takes place, and it is very important because it may damage the network system. Okay, so we will study elements behavior in the upcoming slide. Thank you.